Grounding a detached garage to the house's grounding electrode system is permissible under certain conditions outlined in the National Electrical Code, specifically Section 250.53. B. The core principle is ensuring a low impedance path to ground, which is essential for safety and proper operation of electrical equipment. Firstly, the grounding conductors from the garage and the house must be effectively bonded together. This bonding ensures that both structures are at the same electrical potential, minimizing the risk of voltage differences that could lead to electric shock hazards. Sizing the bonding jumper is crucial. NEC Table 250.66 dictates the appropriate size of the bonding jumper based on the size of the ungrounded conductors supplying the garage. Consulting this table is non-negotiable to meet code requirements. Secondly, the grounding path from the garage grounding electrode system, or GES, to the house GES must have a resistance of 25 ohms or less. This resistance value ensures that fault currents can effectively flow back to the source, tripping circuit breakers or fuses and quickly clearing ground faults. High resistance in the grounding path can impede this process, increasing the risk of electrical hazards. The procedure for implementing this involves several steps. 1. Install a grounding rod at the garage, if necessary, to ensure a low resistance path to ground. While you might be leveraging the house's GES, having a local grounding electrode at the garage can significantly improve the overall grounding performance. 2. Connect a grounding conductor from the garage grounding rod, if present, to the main grounding electrode at the house. This connection establishes the primary grounding pathway between the two structures. 3. On the grounding conductor from the garage to the grounding conductor from the house using a bonding jumper. This jumper provides a redundant, low impedance path for fault current flow. 4. Verify the resistance of the grounding path using a ground resistance tester. This measurement is critical to confirm that the installed grounding system meets the 25 ohms or less requirement. A ground resistance tester, also known as a ground impedance tester, injects a test current into the grounding system and measures the resulting voltage drop. This allows you to calculate the resistance of the grounding path. Several methods exist for testing ground resistance, including the fall-off potential method, the clamp-on method, and the 3-point method. The fall-off potential method is a common and reliable technique that involves driving auxiliary ground rods into the earth and measuring the voltage drop in current flow to determine the resistance. The clamp-on method is suitable for situations where driving ground rods is not feasible, as it measures the current flowing through the grounding conductor. The 3-point method, similar to the fall-off potential, uses 3 electrodes to measure the ground resistance. The distance between the garage and the house is not explicitly specified in the National Electrical Code. However, it is generally recommended to keep the distance as short as possible. Longer distances can increase the impedance of the grounding path due to the increased length of the grounding conductor. This increased impedance can reduce the effectiveness of the grounding system and increase the risk of voltage drop. Voltage drop in the grounding path is a concern because it can lead to elevated touch potentials during ground fault conditions. Touch potential refers to the voltage difference between a grounded object and the surrounding earth. If the touch potential is high enough, it can pose a shock hazard. To minimize voltage drop, use appropriately sized grounding conductors. The size of the grounding conductor is determined by the size of the ungrounded conductors supplying the garage, as specified in NEC Table 250.122. Larger conductors have lower impedance and can carry more current with less voltage drop. Also, ensure that all connections in the grounding path are clean and tight. Loose or corroded connections can significantly increase the impedance of the grounding path. Use appropriate connectors and grounding clamps to ensure reliable connections. Furthermore, consider the soil conditions in the area. Soil resistivity can significantly affect the effectiveness of the grounding system. High soil resistivity increases the resistance of the grounding path. In areas with high soil resistivity, it may be necessary to install additional grounding electrodes or use ground-enhancing materials to reduce the ground resistance. Ground-enhancing materials are substances that are designed to improve the conductivity of the soil. These materials can be used to surround grounding electrodes to lower the ground resistance. Examples of ground-enhancing materials include bentonite clay and conductive concrete. It's also important to consider the type of wiring method used to supply power to the garage. If the wiring method includes a metallic conduit or cable armor, this metallic pathway must also be bonded to the grounding electrode system. Bonding the metallic conduit or cable armor provides an additional low impedance path for fault current flow. This bonding is typically accomplished using bonding bushings or grounding lock nuts. Pay attention to the type of equipment installed in the garage. Certain types of equipment, such as those with sensitive electronic components, may require a dedicated grounding electrode system to minimize the risk of electrical noise and interference. A dedicated grounding electrode system provides a separate, isolated grounding path for sensitive equipment. Also, consider the presence of other metallic structures in the vicinity of the garage. Metallic structures such as fences, sheds, or underground pipes can affect the performance of the grounding system. These metallic structures should be bonded to the grounding electrode system to minimize the risk of stray currents and voltage differences. Stray currents are unwanted electrical currents that flow through unintended paths, such as the earth or metallic structures. Stray currents can cause corrosion, electrical noise, and other problems. To prevent stray currents, bond all metallic structures to the grounding electrode system. This bonding provides a low impedance path for stray currents to flow back to the source. Remember to consult the latest edition of the National Electrical Code for the most up-to-date requirements and recommendations for grounding detached garages. The NEC is updated every 3 years, and it's essential to stay current with the latest changes. Also, consider local amendments to the NEC. Local jurisdictions may have their own amendments or additions to the NEC that are specific to their area. Check with your local building department or electrical inspector to determine if there are any local amendments that apply to your project. When in doubt, consult with a qualified electrician. A qualified electrician has the knowledge and experience to properly design and install a grounding system that meets all applicable code requirements. Attempting to install a grounding system without proper knowledge and experience can be dangerous and may result in code violations. It is recommended to obtain all necessary permits before starting any electrical work. Permits ensure that the work is inspected by a qualified electrical inspector, who can verify that the installation meets all applicable code requirements. Working without a permit can result in fines and may require you to redo the work. And keep detailed records of all grounding system installations, including the location of grounding electrodes, the size of grounding conductors, and the results of ground resistance tests. These records can be useful for future maintenance and troubleshooting. They can also be required for insurance purposes. Regularly inspect the grounding system for any signs of damage or corrosion. Damaged or corroded grounding components can compromise the effectiveness of the grounding system. Replace any damaged or corroded components immediately. And periodically retest the ground resistance of the grounding system to ensure that it still meets the 25 ohms or less requirement. Ground resistance can change over time due to factors such as soil conditions and corrosion. Retesting the ground resistance ensures that the grounding system continues to provide adequate protection. Consider using surge protection devices to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment, and surge protection devices can help to mitigate this risk. Surge protection devices should be installed at the main electrical panel and at individual equipment locations. Also, ensure that all electrical equipment is properly grounded. Improperly grounded equipment can pose a shock hazard. Check the grounding connections on all electrical equipment to ensure that they are tight and secure. If you are unsure about any aspect of grounding a detached garage, consult with a qualified electrician. Grounding is a critical safety issue, and it's important to get it right. Consider the long-term maintenance requirements of the grounding system. Grounding systems require periodic inspection and maintenance to ensure that they continue to function properly. Develop a maintenance plan that includes regular inspections, testing, and repairs. Furthermore, document all grounding system modifications. If you make any changes to the grounding system, such as adding new grounding electrodes or replacing grounding conductors, be sure to document these changes. This documentation will be helpful for future maintenance and troubleshooting. Think about the potential for future expansion of the electrical system in the garage. If you plan to add more circuits or equipment in the future, make sure that the grounding system is adequately sized to handle the increased load. It may be necessary to install additional grounding electrodes or use larger grounding conductors to accommodate future expansion. And consider the impact of the grounding system on other electrical systems in the house. Grounding systems can affect the performance of other electrical systems, such as sensitive electronic equipment. If you experience any problems with other electrical systems after installing the grounding system, consult with a qualified electrician. Remember that the primary goal of grounding is to protect people and property from electrical hazards. A properly installed and maintained grounding system can significantly reduce the risk of electric shock, fire, and equipment damage.